I am trying to make now 2026 a radio oscillator that can work between, say, 10 megahertz and 20 megahertz. And I want to refer to the earlier video that is on my YouTube channel. I will give the link. Here is that typical circuit, and I've now connected here a coil. You can see the amount of windings, etc., etc. And I've used no, say, varactors, but only simple silicon diodes that act as a varactor. And I will show the schematic. We set the bias of the oscillator here with that potentiometer, and that's very, very important. Of course, you have to find a setting of that potentiometer that biases the oscillator to a position where the coil that you want to use and want to use it for a certain frequency works. Anyway, so this is the schematic now, and of course it's completely experimental. It refers to the earlier schematic that I published on YouTube, where a BD 140 PNP transistor, normally used for audio purposes, was used to make an oscillator in this frequency band, say 10 megahertz up to XX megahertz. I want to refer to the earlier video where this is showed. Anyway, so what's it all about? I found that 18 volts work nice. It's quite high, by the way, but anyway, again, it's an experiment, and well, short wave radio oscillator for 10 to 25 megacycles. First try, and indeed it is a first try derived from the earlier circuit that I published on YouTube. And at the moment I'm working on this part here. I want to have a oscillator that works in this frequency range, but 10 megahertz up to 20 megahertz. Well, that's always in a certain way a problem because of the stability, temperature problems, etc., etc. When, say, a coil gets a higher temperature, the frequency will change. Also, that also refers to capacitors that bridge an oscillator coil. But anyway, I'm working further on it, and because this is all hobby and, say, interesting things, because of the fact that we are now going to 10 up to 20 megahertz, I've used another approach. You can see, say, the tin plate, it's glued here on the back side to aluminum, and here are all the knobs, etc., on the front. And it's important to tell that, of course, we have to avoid hand effect as good as possible. So that's a reason why we have here tin plate that is steel. Steel is the most best property to shield against hand effect, and I've glued steel here to the aluminium front plate. So here is that aluminium front plate. Anyway, so I hope it will be a successful circuit to make a radio oscillator in this higher frequency band. There are many oscillator circuits on my YouTube channel that regard radio reception, shortwave radio reception, and then I mean AM, amplitude modulated radio stations. I've never focused on frequency modulated shortwave radio stations, etc. But anyway, this is what it will be all about. And of course we know that such a circuit, though it looks very nice, can also fail. So anyway, let's go back to the schematic. I've used here a normal silicon diodes as a varicap. You can see that here on the schematic. Here 1N5408. You can also use another silicon diode, standard diode, to be used as a variable capacitor. That variable capacitor gets its voltage here via that 4K7 potmeter and 470 kilo ohm tuning capacitor. My idea is to make also here a fine tuning with another another potentiometer, but anyway, it's all experimental. And well, I've tested this and it worked. Strange to say that the BD140 is a normal PNP transistor, can also work as a high frequency oscillator. I had not expected that, but I tested that in the future and I could get to approximately 110 megahertz. Anyway, so here we have the bunch of diodes that function as a varactor, variable capacitor. They parallel the coil here that is responsible for the frequency band, and here is the switch that I'm going to use here as a frequency switch. This coil is horizontal. My idea is that I need here two coils. Correct me if I'm wrong, but anyway, two coils, and one is vertical and one is horizontal and one is vertical, because they don't have to couple. That will have an effect on the frequency where it all will work. And more important to tell, perhaps I need a very small capacitor here from the emitter of that transistor here to the ground in the order of 10 picofarad to make the waveform more pure. Thanks for watching. This is the waveform at the moment, and we are on, say, 20 megahertz, quite high. Let me try to change a little bit on this, and of course on a certain moment the oscillator will stop. So there is a critical relation between, well, this broke off, but anyway, I don't want to do this video all over. Thanks for watching again. It is, in my opinion, a quite good experimental circuit for radio applications, a sine wave oscillator in that higher frequency band, say 10 megahertz up to approximately 20 megahertz or perhaps even higher, and that depends on the coil that you use here. The amount of windings, here is the amount of windings at the moment, and you can shortcut a part of the coil to get to higher frequencies, and I will try to do that in the future when this all works out. Thanks for watching again. Let's go to the schematic. And pan over.